Now today we are going to see the hydraulic dynamometer, which is one of the type of absorption type dynamometer. So as we know, in every absorption type dynamometer there is action of braking. In case of rope brake dynamometer, the friction between rope and wooden block. In case of prony brake dynamometer, there is a friction between the flywheel and the wooden blocks. Now similarly, in case of hydraulic dynamometer, there is action of braking due to the hydraulic fluid. So here we are considering the fluid is nothing but the water. Now this is the figure of hydraulic dynamometer, in which there is an engine shaft on which the rotor or rotating disc is mounted. On the other sides, the casing is mounted, which is also known as a stator. The casing is in the two halves. See this, one half is at the right side of the rotor, another half is at the this side of the rotor, and this casing is free to rotate. But the rotor, if the rotor rotates, the speed of the rotor as well as the speed of the shaft is same, because it is mounted on the engine shaft. Now it's operate on the water brake principle, used as fluid friction rather than dry friction. So here the medium water is used for the friction purpose. So it is the kind of fluid friction, not a dry friction. Now as water enters into this part, see the water inlet is here and water outlet part is here. So as water enters, and suppose the rotor is rotating, so because of this action, the vortex chamber created or vortex action takes place. Vortex is also known as the turbulence created, and due to this turbulence, this tends to turn the casing in the direction of the rotation of the rotor. So it try to pulling the stator in this direction. So the stator to rotor direction or movement is opposed by the arm with the balancing weight. So here there is an arm with the balancing weight. At the second figure you can see the stator to rotor movement is opposed by the arm with balancing weight, and here because of the balancing weight the torque is measured. So this perpendicular distance and the balancing weight, so W into perpendicular distance, the torque is measured in the torque meter. The control of braking by changing the quantity of water pressure. So here the control of braking can be changed due to the quantity of water pressure passing through this channel, that is water inlet, or the changing the space between the stator and rotor. So in both ways you can control the brakes. First one, that is changing the water pressure, and second one to change the gap between the stator and the rotor. So which is very it is one of the easy type of dynamometer, so in which only the water is used as a medium for the braking. Rotor rotates, the stator is rotating freely. So as water enters, so due to water speed and the rotation, it creates the turbulence, and turbulence try to pull the stator in this direction. So this direction opposed by this arm, so in which the arm connected to the torque meter, and here the torque is measured. So controlling, as I told you, the control action takes place by the two ways. The first one, changing the water pressure, and changing the space between the rotor and the stator. Now here how the power is calculated. The power formula is W into N divided by the K. So W, that is a balancing weight placed at the end of the lever arm. So here, next, speed of the speed of the shaft in RPM. So here in tachometer the speed is measured. K is dynamometer constant. So here the range I have mentioned, the range of this dynamometer to measure power up to 20,000 kilowatt and speed up to 10,000 RPM. These are some advantages. Water supply used for the braking and the cooling purpose. So here no extra cooling is required. High absorption capacity in a small pace, that's why the cost is very low. And the last advantage, it is used for high power measurement at a high speed. So I hope you understand this hydraulic dynamometer. Thank you.